So let's evaluate this question. It states calculate the probability of getting heads in a fair coin tossed one time. Well, you all must have studied in probability that this probability will be equal to 1 by 2, but we'll be using quantum mechanics in this video to solve this question. So let's start the lecture, but for that is to like, share, subscribe and please support this video. Now let's start. So first of all, let's define a state vector over here. So state vector is equal to, these are the basis vector. Since when you toss a coin, you get either heads or tails, but in quantum mechanics it can be in a mixed state, and hence we are implementing the superposition principle in this, right? So this is the basic idea, and these are the basis vectors, the heads and the tails, the state of being in head and the state of being in tails, they are the basis vector over here, right? So you can define it like this also, that the basis vector is equal to this, and that this vector you can represent it like this. Okay. Now one more thing I need to tell you over here, that when you take their inner product, heads with heads, you will get 1, and when you take the inner product tails with tails, you will get 1 again. But when you take the inner product of heads with tails or tails with heads, you will get 0. Why? Because these are the basis vectors and they are orthonormal, right? Since they are orthonormal, hence their product must be equal to 1 when taken when both are the same basis vector, and if they are the different basis vector, they must be equal to 0, right? Okay, so let me explain it also. Suppose there are these are the basis vector ai and aj, right? So when you take their inner product, and if they are orthonormal, they must be equal to Kronecker delta ij. What is Kronecker delta? Ij, it is equal to 1 if I is equal to j and 0 if I is not equal to j. Understood? So this is basically, this is the idea, right? Now first of all we have to evaluate a and b, right? Okay. Now since it's a fair coin, hence it means that a and b must be equal, right? They must be equal. Hence it won't be a fair coin, it will be a biased coin then, right? Okay. Now how we can evaluate? So we know one thing, that a is equal to b, right? That's it, what we know. Okay. So now we can use the inner product of psi with psi, and it must be equal to 1 because we know. Hence, what is this? It is a, this is the ket vector, right? And now we have to convert it from a ket to brass. So what we can do is that we can apply over here the rule. So it will be equal to a star plus b star and over here. Okay. Now we can evaluate this. Sorry. So basically it is the conjugate. Okay. So just apply over here. So we will have this expression plus, and now you can just multiply it, right? You all know how to multiply. So let me tell. Okay, so just multiply. You will have over here a star a, inner product of h with h, plus a star b, inner product of h with tails, b, inner product of tails with h with heads, plus b star b, inner product of tails with tails, right? Okay. Inner product of heads with tails is equal to 0, and inner product of tails with heads is again equal to 0, and this is equal to 1, this is equal to 1. So what is a times a star? Well, it is equal to modulus of a square, right? So it is modulus of a square plus modulus of b square, it is equal to 1, right? Since the total probability is equal to 1, right? Okay. And since a is equal to b, hence their modulus must also be equal to right? Hence mod a is equal to 1 by root 2 and mod b is equal to 1 by root 2 again. So we have the values that mod a is equal to 1 by root 2 and mod b is equal to 1 by root 2 again. Now what we have to calculate? Well, we have to calculate the inner product of heads with psi. So now let's evaluate that. So the probability of heads will be the inner product of heads with psi modulus square, right? So the probability is equal to the mod of psi square, right? So that is the concept over here. So this is the vector, this is the state vector, and this is what we want, right? So that is what we are going to do. So again, it will be, so first of all you have to calculate this inner product. So it is equal to times this quantity. What is the ket psi? It is equal to a. These are the basis vectors, right? T, right? Okay. Now just evaluate this. You will have a inner product of h with h plus inner product of h with tails, and this is again equal to 0. So it is equal to a. Hence the probability is, the inner product is equal to a itself, right? Now since it's equal to a, so we have to calculate p of h, modulus of h inner product of h inner product with psi whole square. So it is equal to basically modulus of a square, which is equal to 1 by root 2 square, which is equal to 1 by 2. Hence probability of heads is equal to 1 by 2. So I hope that you enjoyed this video. If you did, then please do like, subscribe, and please support this video. And if you want to learn more on quantum mechanics and special theory of relativity and general theory of relativity, just let me know in the comment section. I will make more videos on such topics and such calculations which are not available on YouTube. So stay tuned. Bye bye. Take care.